Okay, so this is the second part of section 3.1, compound interest. The first part was pretty simple, annual compounding. Well, unfortunately, in most compound interest calculations, the annual interest rate, or annual interest rate, is called the APR, the lowercase r. That does not represent the true return on your money for the year. All right, and that's because the compounding is not usually calculated just once a year. Sometimes it is, and if it's only calculated once a year, we call that annual compounding. Okay, but many times it compounds more frequently. And in fact, we will use the letter K to denote the number of compounding periods per year. And the number of compounding periods per year, of course, depends on how frequently we count or we calculate or we let the compound interest appear on your statements and so on. We use adverbs like quarterly or monthly or daily. Okay, so what does it mean? Well, quarterly means we calculate interest every quarter. What is every quarter? We have 4 quarters, and so that's every 3 months. Every 3 months, you get the a payment of interest added to the account, right? Monthly, of course, means K is 12, and so this is every month. And this is typical, right? I mean, most of you have a bank statement coming to you every month, and they will calculate interest every month, okay? Daily is also possible, not as popular, not as widely used, but K is 365, and that means every day they calculate how much you get. And in some financial sectors, this is the standard. And then in the next section, we will take this to the extreme. You can do every day, and theoretically, you can do this every hour or every minute and every second. And then you can even go to say, we will calculate interest on a continuous basis, like every moment, every split second, but even more than that, continuously. And it does actually make sense as K goes to infinity. Okay. You guys all know the sign or symbol for infinity. It's the sideways 8, and this represents infinity. And we can extend it, and this will give us a sort of a limiting formula. Now, what does it mean? All right, so this is very important because this is counterintuitive. In fact, I don't like the way the financial industry uses this this language, but since it's conventional, we will need to know what that means. All right, so when people say, or when a financial institution says, for instance, you will get an interest rate of 12% compounded monthly, they wouldn't say that today because nobody's going to give you 12% anyway. Maybe you can get 0.12%. Okay, but suppose somebody says you will earn the interest rate at 12% monthly. This does not mean that you will get 12% every month. Now that would be extremely a good thing, right? I mean, for you to be saving money, because every month your money increases by 12%. That's not going to happen. What they mean by that, it's it's every month, and for the whole year it's 12 months. So you divide 12 by 12 and get 1%. So this means 1% every month. And so they will calculate maybe at the end of every month your 1% interest on the previous month's account and add that interest to your account. And then the next month, they will do the same thing. They will add 1% and so on. Every month, they will add 1% to your account. And interestingly enough, and maybe you see this coming, because of the compound, not linear growth of compound interest, once you find out how much you will earn in 1 year, it's not exactly 12%. It's going to be more than 12%. So even though they say 12%, this is your APR, this is your, it's not ARR, it's APR, which we denote with the lowercase r. 12% is your APR, but the real annual percentage yield that you will get with 1% every month, which is what they mean by that, is not going to be 12% exactly. It's going to be more than that. So in that sense, okay, the annual percentage rate, the term annual percentage rate is a little deceptive. Okay, but this is what they mean by that. So let's go ahead and do another one. 12% quarterly. What do you think this means? This means 3% every quarter, every 3 months. Okay, so how am I getting this? Okay, you can tell all I'm doing is I'm taking that R and dividing by the number of times compounding is calculated, which is K, right? This is the number I was referring to here. And so this is called the rate per period. This is the rate you are actually getting per the compounding period, whether it's a quarter or a month or day or whatever, okay? So this is by far more important than that R itself, because this number, this ratio, R divided by K, will appear in almost all of the formulas. And in fact, let me just give you the formula right now. See, what happens is, once you have R, this is, so this is your interest rate per period, right? So every time you calculate your interest, you're taking 1 plus this rate, R divided by K. For instance, if it's a 12% monthly, you will be adding 1% every month. So this is the number, that number which is the base of your exponentiation or your exponential growth. Right? So 1 plus R over K. So R over K must be calculated first. Okay. And if it's 12% monthly, that's 1% every month. And so even if it's for 1 year, you have 12 periods, right? 12 months. So that's what it's going to be. If it's for 2 years, guess what? It's going to be 12 times 2, because 2 years means 24 months. And this is what you have to multiply with P in order to get your account. Okay, so this is for 2 years. This is for 2 years and monthly compounding. Okay, so you can generalize that. And if I denote with this A sub T, I don't want to give you many formulas. And this is one of the exceptions where you probably have to use this formula over and over again in chapter 3. So you probably do need to know this formula, but instead of just memorizing what's given, try to understand where the formula is coming from. Okay, and this is really about the mathematical thinking is like, where did this come from? Can you derive it based on examples like this? Right? So A sub T, this is the amount after T years, is going to be the principal multiplied by, right, 1 plus that R over K, the rate per period. Now the thing is, I have to multiply this many times together, okay? Just like I did on page 1. That was just the number N, the number of years, right? But here, I have to take this to the exponent, which represents the total number of compounding periods, because that's how many times I'm going to calculate this. And that is K times T, right? Because K is the number of compounding periods per year, T is the number of years, right? So maybe I should denote this KT, that happens to be the name of my friend, great mechanic. KT is the total number of compounding periods, total number of compounding periods. And as I said, R over K, which you will see often, is the rate per period. Okay, so this is the formula that you will need to use for most of your exercises. And by the way, if K happens to be 1, then this is 1 and this is 1, and you'll have exactly the formula you saw back on page 1. So this is the better version. This includes the annual annual increase, which you studied on page 1. So in that sense, this is more general, which means that the first formula you learned was just a part of, or one application of this more general formula. Okay, let's do a couple of examples here. Suppose P is 3,000. Okay, you deposit $3,000 today. How much will you have in 5 years? Okay, and by the way, you should notice here, P is given as 3,000. And what's 5? This is T, right? T is 5 years. All right, so under A, we will calculate how many how much you have after 5 years, and that is, and let's see, what is that? 3% quarterly. Yeah, maybe that's what I need to calculate first. 3% quarterly means R over K. What's R over K? It's 0.03 divided by 4. Okay, and you don't really have to know what that number is. Okay, we will embed that in our calculation. A5 is going to be, maybe I should write it. Yeah, let me go ahead and write this over here. All right, so A5 is P, $3,000 times, if you don't put anything, it's a dot, it's multiplication. 1 plus 0.03 divided by 4, parentheses, raise it to what power? Okay, so this is quarterly for 5 years, right? There are 20 quarters in 5 years. And so this part is KT. The exponent is 4 times a year times 5 years. So you can see this represents the total of 20 compounding periods in the 5-year period. This is what you will have to calculate, okay? Now, I'm going to show you how to do this in a few minutes, but if you do this right, you get $3,483.55, okay? And that is your solution for this question. For B, it's 12% annually. R over K is, of course, 0.12 divided by 1, right? And that's 0.12. So this is the simple thing that we did on the front page, and that's 1.12 raised to the 5 years. And in 5 years, you have only 5 annual compound interest periods because, this is once a year. Okay, so you can calculate 1.12 raised to the 5th power and then multiply that by 3,000. You get $5,287.03. For C, R over K is, well, look, this is 12% monthly. So you divide it by 12. 12% monthly, remember, means 1% every month. Okay, so that is supposed to add up to 12% for the whole year because you do this 12 times. And as I said before, 12% monthly actually does not equal 12% for the entire year, but that's okay. We take A to the A sub 5 is 3,000 times 1.01. Okay, that's, remember, that's 1 plus R divided by K. And then you raise it to what power? 12 times 5, that's K times T, that's 60 months, right? Because if it's 12 months a year for 5 years, that's 60 months. And that is the number, 60 is the total number of compounding periods in this question. So you take 1.01 raised to the 60th power, and you multiply that by 3,000 to get 5,450.09. Okay, let me show you how to do these calculations on your calculator. Okay, get your calculator out. Let's do this together if possible. For part A is actually the hardest one of these 3 questions. All right, so I recommend that you do the inside part. Let's try to find 0.03. You see that? Divided by 4, and that's not a very nice number. And that's 0.0075. Okay, it turns out 3% quarterly means, what is that? 0.75%, or 0.75% every quarter, right? Now you add 1 to it, so plus 1. And this is the base, or this is inside the parentheses. You raise it to what power? Oh, not multiply. Sorry about that. Let's go back and erase that. Can I do that? No, I can't. Let me go to start all over again. 0.03 divided by 4, add 1 to it. And so this is inside the parentheses. Now you raise it to the power of, notice you use this key to the what? And remember, it's 4 quarters for 5 years, so that's 20, right? And so that is the exponential part of this. And all you have to do now is to multiply this by 3,000. And you get your answer for the first question, $3,483.55, rounded to the nearest cent. Okay, now clear. And how about the next one? The next one is easy because it's annual. 1.12, this is 1 plus r, raised to the power of 5 years. And you multiply this by 3,000. And you get $5,287.03 if you round this 5 up to the next number. So 2 becomes 3. All right, so it's $5,287.03. But okay, and by the way, this is 12% annually. If you calculate your balance for 12% monthly, you will get a number more than that, because it turns out the more frequent the compounding is, the more money you will end up with. All right, so in that case, you have 0.12 divided by 12. Of course, you can do this part in your head. 12% compounded monthly means 1% every month. Add 1 to it. Make sure you put the equal sign so that you can find out what that inside base is. And then you raise it to the power of what? Okay, 12 times 5 is 60. And by the way, if you can't do that multiplication, maybe that the number of years is more complicated. You can use the parentheses if you like. Okay, but in this case, it's 5 years every month, so it's 60 compounding periods. That 60 represents KT, which is the exponent. And then you can say equal to it. Again, it's a long, big number. Multiply that by 3,000. Oh, not 3. There, okay. This undo key is a wonderful invention. And then you put equal sign and you see $5,450.09. Okay, so that's how you can do these problems on your computer. The calculator. All right, let's do the last 2 questions here. Suppose you have an unknown relative who just passed away, and that uncle, maybe a relative, left $1,000 for you in an account at your birth. Okay, hoping that you would attend college, maybe College of the Canyons, wherever, when you are 18 years old. Okay, so the money has been sitting there for 18 years because now you're 18. This is the assumption. The money has earned a high interest rate of 6% monthly for 18 years. Okay, so the money, the $1,000 was deposited at your birth. It's been accumulating interest, earning interest at 6% every month for 18 years. And of course, this means 0.5% every month. This is the APR, right? And so you would have to divide. Let's go ahead and do that. Because in this case, every monthly, K is 12. So R divided by K is 0.06 divided by 12, and that's 0.005, otherwise known as 0.5% or half a percent every month. How much money would you have on your 18th birthday? Okay, and at that point, you can use that money to buy some textbooks, unless you use an OER textbook for your class. All right, so let's find out. What is the amount after 18 years? We denote that as the amount sub 18. A sub 18 is equal to 1,000 times 1 plus, remember, we already calculated this part, but I'm going ahead and writing this down. Of course, this part just becomes 1.005. You raise it to what power? 12 times 18, right? You can calculate, by the way, 12 times 18 separately. All right, and you will find that it's 216, but you don't have to. Okay, and I will show you how to do this quickly right now, and then we can write down the answer. Okay, so this is a good time to discuss how to use that parentheses if you are able to do that. Otherwise, you can just multiply 12 by 18 and get 216 as your exponent. But this is how I would do it. So you take 0.06, that's your APR, divided by 12, and add 1 to it. This number, 1.005, is the value within the parentheses, okay? Then we raise it to the power of, and we say, that's 12 times 18. How many months are we talking about in 18 years? So that's when you can use the parentheses here. 12 times 18, and then you close the parentheses. Okay, so now you are about to raise 1.005 to the 216th power. This is your answer. You multiply this by 1000, and that is your answer. You will get close to $3,000 today. More specifically, $2,936.77 when you round to the nearest cent. Okay, go ahead. Let's go ahead and write this down. That number is $2,936.77, thanks to your unknown relative who left $1,000 to be invested for 18 years, because now that $1,000 has grown to be about $3,000, and you can maybe buy a couple of textbooks for that price. Okay, you want to save, this is a slightly different kind of question. I think you will have a question like this in your homework. You want to save some money to buy a car in the future, okay? And you found a way to make your money grow by 8% quarterly. That's good. Let's go ahead and identify what this is telling us. Your annual percentage rate, R, is 8%. Quarterly means K is 4, right? And you may as well find out this number, which is the rate per period. You notice here it's 2% every quarter. When they say 8% quarterly, that means 2% every quarter, supposedly adding up to 8%, but technically more than 8% for the year because of the exponential nature of the growth. If you want to save, or if you want to have $20,000 in 3 years, so T is 3, how much will you have in the deposit today? So the thing is, this is a question that we haven't seen before because we are asked for the value P. You do know how much money you would want to end up with, right? So A3, which is 20,000, 20,000, okay, down payment for your car, your future dream car that you would like to buy in 3 years, is equal to P times, and we don't know what the P is, 1 plus 0.08 divided by 4. And how many compounding periods do we have? For 3 years, 4 times a year. Okay, so that's 12, right? You could write this, by the way, as follows. Okay, I'm going to write this in a backward way. So we don't know what P is, but this part here can be written as 1.02, right? Because that's inside the parentheses. 1.02 raised to the 12th power times this principal P is 20,000. And so what you have to do to find P is to divide both sides by this, okay? So P turns out to be 20,000 divided by 1.02 12th power. Now, if you don't like doing this in one shot, okay, you can go ahead and calculate this amount, write down all the decimals, as many as possible, so you don't have a round of error, and then you divide that number by into 20,000. So it's 20,000 minus divided by whatever you came up with, right? So you can do that. And so let me show you how I would do that, and that would be the end of this section. Okay, so if you want to write down the number first, you can do 1.02 raised to the power of 12 and go ahead and write down like 1.26824179, you know, like bunch of digits. And then you can divide 20,000 by that number. So that's one way to do that. I am not going to do it that way. I like to sort of do this in one simple or one series of operations. So what I will do is 20,000 divided by, okay, now again, my calculator is so smart, it knows the order of operations. If I do 1.02 raised to the power of 12, the calculator is going to find 1.02 to the power of 12 first, and then divide that number into 20,000. So all I have to do at this point is to hit the equal sign or the enter button to get my answer, which is $15,769.86. And that would be the answer to that question. Okay, so just to finish out this problem here, it's $15,769.86. Now, if you're off by a few dollars or a few pennies, that's okay, because you are doing this right. It's just a rounding error. But if you're off by, you know, more like $1,000 or something, then you may want to check again to make sure that you are doing this correctly. Okay, so that concludes this particular lesson. By the way, the last one, if you want to say this in sentence answer, then you say, today you will need to deposit $15,769.80 today, so that you can have $20,000 in 3 years. That would enable you to buy that car. Okay, you should be ready to do this quiz for section 3.1. If I were you, I would do all of these problems on this paper on your printout, and then when you go to the online questions, which are the same, then you can just write down the answers, all right? But your work should be here, and you should keep your work here, and keep your piece of paper, this page of your notes, so that you can study before your exam. All right, so that is the first section of chapter 3, and we will continue to discuss money in the next few days. Have a wonderful day, and see you later.